Hello everyone, my name is Jean-Claude Burgerman. I'm the Professor of Open Science Policy at the Free University of Brussels, and I used to be in charge of open science and open access at the European Commission for a couple of years. I welcome all of you to this new edition of the Frontiers Policy Lab, which is an initiative taken by Frontiers to bring to the forefront policy discussions on the future of science and policy, and more in particular from the point of view, what did we learn in this respect from what happened since the world was hit by the COVID-19 virus and all the subsequent effects it had on science policy, on the way science is done, on the way the science community and the ecosystem reacts, and trying to think the mid to long term consequences of that. So it is a platform for a dialogue between experts around the globe and in Europe to come up with new ideas, lessons learned, and so forth. As part of this initiative, today I'm speaking to Professor James Wilsdon, who is the Digital Science Professor of Research Policy and director of the last year, if I'm correct, James, yes, I'm correct. So the last year created Research on Research Institute, so the Rory Institute at the University of Sheffield.
Thank you, Jean-Claude, again for the opportunity to be here, and thanks for the chance to take part in this very interesting series. So I'm based, as you say, primarily at Sheffield University, where I'm Professor of Research Policy. I'm also the inaugural founding director of this new Research on Research Institute, which we launched towards the end of last year. And this is based physically down at the Wellcome Trust in London, but is a partnership between Wellcome, my own university, Leiden University in the Netherlands, and Digital Science. And the aim of this new institute is to undertake transformative and translational research on research. So we're looking at how research systems, cultures, decision-making operate, and bringing together a range of key actors in research systems to try and share data, undertake real-time experiments, and in that way shed more light on the sort of inner workings of the research system that merit more analysis and scrutiny. Clearly, one of the biggest vectors of disruption is the macroeconomic, and as we're already seeing in many countries, the turbulence that's going to flow from this pandemic will be considerable, and is likely in quite a number of systems to hit negatively on the line of investment. But set against that, you've got all of these huge positives, as you've already outlined, in terms of the speed and force with which the science system has engaged in the response, both the first wave response, investment in vaccines, diagnostics, therapeutics, etc. And also now, as we start to see the emergence of second wave responses in the research system. So, if those first waves are about addressing the virus itself, second wave responses are then looking at ways in which the effects of the virus on the economy, on society, on health systems more broadly, what kind of research questions and imperatives flow from that. And we're beginning to see now funding going into those kinds of questions, but that's inevitably going to pick up over the next year or more. The really big unknown, or if you like, the third wave effects, what will happen over a 2, 3, 5, 10-year time frame as a result of this. And I think that's the really big meta research question that we're only starting to be able to answer, really. One of the most interesting dynamics of that longer term debate is the extent to which the acute and huge challenge of addressing this specific virus, COVID-19, whether that triggers an enormous wave of further investment in related biomedical and health related research, other forms of pandemic preparedness, investment in vaccines more broadly, etc. And how that priority, because it clearly is a priority. I mean, I don't think anyone would come out of the last few months and not see that area as one that requires more investment. But how you balance those priorities with then other dimensions of resilience and preparedness for other types of crisis that may well hit us with every bit as much as of a sort of shock or come from left field in the way that coronavirus did at the start of this year. Now, those might be climate related. They might be, it might be, I was talking to an astronomer not long ago saying, it might be an asteroid strike. Who knows? But I think out of this episode comes both the imperative to invest in the specific, but also more than ever, an argument for a broad spectrum of investment in capacities to deal not only with the crises that we know about, but with the crises that we don't yet know about. The going back to our old friend Donald Rumsfeld and his known unknowns and unknown unknowns. It's the investment across the spectrum that I think, for me, is one of the big priorities that fall out of this. And I guess the challenge politically will be whether, given, going back to my earlier point, given the constraints we're going to see on public spending, most likely as a result of this, whether the argument for that sort of full spectrum preparedness can be easily made and won by the research system, by the research community, with politicians and ultimately with the public.
In a certain way, we need to have this kind of system preparedness for all the potential disruptions which we will have in the future. Some of them will be health related. Some of them we know, like obesity. Some of them we don't know, like we didn't know COVID. And that's one part of it. But then there is all the rest, the climate change stuff, the biodiversity stuff, the food quality, the nuclear challenges in terms of nuclear arms and so on. So trying to figure out a world system that keeps track of these signals and at the same time translates that into science policy and science funding policy, I would think that is an enormous challenge of the future.
We've shown that under situations of extreme stress, i.e. an imminent, very real threat to health systems and public health from COVID-19, we can make the system work in all sorts of ways that convention would tell us isn't possible, or it can't be done in that way, it can't be done that quickly. Having done it now in this way for this particular emergency, I think it's quite proper to come out of the end of this, whenever that end is, and the end is clearly still some way off, and ask, well, if we did it then, why can't we do it as a response to the climate emergency? Or what is it about this particular crisis that has enabled the kind of responsiveness, agility, innovation that we've seen, that has still proved more difficult when it comes to other major systemic changes. And I think that's a very important question for the research community to engage in. I mean, clearly it's also a political and public question as well. It's not simply for us to decide, but I think, even at a sort of at the level of science communication and publication, as we've seen, if publishers and others can, at a stroke, make all research related to COVID-19 100% open overnight, why is it that it's possible to do that for a pandemic, but it's not possible to do it for climate change, when we know, we have data coming out of our ears in terms of the severity of that, the latter threat as well as the former. I think for me, one of the very interesting questions coming out of this whole episode for debates around health research spending, and from that debates about balance more generally, is why is it in a country like the UK or the US, which on any conventional measure of scientific investment and output have two of the most sophisticated biomedical research systems in the world? I mean, I think we would Germany, one or two others, but they're certainly up there in the very top echelon. And yet those two countries, I'll leave Belgium and others out of it for the minute, but those two countries certainly have come out of the pandemic with among the, clearly the situation is still evolving, but among the worst performing systems overall, at least with respect to mortality related to COVID-19 and case numbers, etc. If on the one hand you've got all of this incredibly world-class elite research science going on, and I mean, we're obviously playing a role there in the quest for a vaccine, and Oxford, Imperial, and other places are at the forefront of those efforts, which is fantastic. And yet we still had a chronic collapse of our capacity to deliver basic public health precautions and measures, and the delivery of PPE and all this sort of thing at the front line of the health system. And I find as a research policymaker, I mean, that's a very, very uncomfortable challenge that's been posed by this, and I think the same would apply in the States. And I think we need, to my mind, I say I don't want to hastily draw points here, and I'm also cautious. People have talked about the sort of so-called coronavirus confirmation syndrome, where you look to the pandemic to sort of reinforce things that you've thought all along, and maybe I'm guilty of that in making this point. But nonetheless, I think, to me, it reinforces this sense in which aspects of if you like, the sort of elite end of science and research have become ever more decoupled from actual societal and economic needs. In that up here, they're primarily, not all the time, and obviously if they're developing a vaccine, that's fantastic, but primarily they're performing and playing in a game that is a quite self-referential scientific game to do with, where you publish, what you produce, etc., etc. And down here we have, elderly people in social care with no access to basic, health protection. The kind of mindset that countries that had lived through SARS had towards the emergence of coronavirus was very, very different to the kind of British and probably the American mindset, which certainly in our case, as you say, looked at it initially as the primary corollary being influenza. Had we had a more connected, as it were, expert discussion, perhaps that wouldn't have happened, but we sort of seem to need to recreate at a domestic level all of the advisories, which seems to me very odd, given it was a global pandemic and we could see what was coming, if we looked at China, if we looked at Italy, etc., and yet we seem to need to reinvent all the advice domestically, or somehow not trust the experience of the Chinese or the Italians or anyone else when it came to what was about to unfold in Britain and then again in America. Where there were serious shortfalls were with respect to the behavioral aspects of the system. So you had, very expert epidemiologists, virologists, etc., who really could understand and model and map the trajectory, the pathway of the virus. But when it came then to how people would respond to lockdown type measures, all sorts of assumptions were made that weren't really grounded in the same kind of empirical data or even more solid modeling that other bits of the system were. And so assumptions were made that in retrospect look very clearly to be at best debatable, at worst entirely wrong. And it was those kind of failings, and that to me again is an indicator of a lopsided system where we've invested a lot here but not so much here, both in terms of investment in research funding but also in the associated sort of epistemic status that we give these different knowledges in the system. So when it comes to the construction of a scientific advisory body to deal with a pandemic like this, so we had here the Scientific Advisory Group on Emergencies, which was convened to respond. One thing that I would observe from having studied and analysed many research systems around the world over my own case now, so 25 years, diversity as a principle is one of the few things that really does matter in a research system. And by that I mean, yes, diversity of funding mode, directed, undirected, problem-oriented, more open-ended, etc., etc. Diversity of discipline and then of other orientations, user-defined, user-led, co-produced research, etc. And then, of course, we get into the actual diversity question as it pertains to the scientific workforce and all the questions there around equality, diversity, and inclusion, where again diversity is a very important feature. So I think we at a design level, this argument held before the pandemic, but it holds even more coming out of it, and it goes back to this COVIDization point. COVIDization at its worst worst, at its most negative, could mean a restriction, a limiting of diversity as we focus perhaps less available resource if other economic constraints kick in on a narrower set of questions, which may be very acute questions, but they still will be a narrow set of questions. And I think that would be problematic in that it will store up fragilities and weaknesses in the system over the medium long term, and we won't really know what those weaknesses are until they hit us, just as we didn't know about many of the aspects of weakness that we've just been living through in recent months. We weren't properly cited and on top of those, that's a negative. A positive shift into the COVID. I mean, if COVIDization if one says one of the lessons of COVID is exactly as we've been saying, that you need this breadth, that you need, if COVIDization of research systems in that sense is interpreted as a shift towards more investment in problem orientation combined with breadth, inter and transdisciplinary capacity combined with deep specialist subject trained knowledge, where that to me is a positive form of COVIDization. So I guess there's a battle still to be fought for if we're going to sort of think about it in terms of COVIDization, a battle in terms of defining what sort of COVIDization, what do we mean by COVIDization? Do we mean the sort of negative features of the COVID episode, or the positive ones that we now want to see magnified and amplified through research systems more broadly? And clearly, I'm sure you and I would agree it's the positives, but it's not a done deal that we go in that direction.